So again, anytime you have data in a chart, you could put those numbers into a box and make a matrix. So what we're going to do is we're going to create matrices with our data, and we're going to see how the matrix multiplication actually allows us to solve these questions. So here we've got a store, 4 stores. You must be the supplier for all of these stores. And they want to buy balls, bats, and gloves because they're all baseball stores. Or maybe you own a Sport Chek and these are 4 different Sport Cheks across the city or across different cities. And they need these things and you need to charge each store for how much they get. So the total order as a matrix A is just putting those numbers into a box. But what I'm going to do, because it's a word problem, is in purple and black here, I've just added some labels for myself to remember what things were. And, oh my goodness, I was going to use B for balls. But then bat started with B. So I used BA for balls, and then I was like, bat starts with BA. I ended up having to write all the word bat out. And yeah. But usually I just use a single letter. Just quick remind myself what it is. Now, this makes what size a matrix? 4 by 3. Matrices are up. 4 rows, 3 columns. And I'm going to go and I'm going to put this matrix, and I'd like you to take out your calculator and put this into your calculator as well. So I go second matrix. I'm just going to overwrite. So I'm going to go over to edit. I'm going to write it in matrix A. I know that we had a matrix in here the other day. We don't have to delete it. I can just go 4 by 3, and it automatically adds those new things, and then I don't even have to hit delete. If I just start typing things, it just replaces them. So 70, 30, 22, 60, 20. If you push enter in between, it just automatically jumps to the next one. 70, 50, oops, 15, 24. 50, 40, 12. So we got matrix A now. And I put it in A because in our question we also said call it A. So this is going to help me remember what's happening. There's my matrix A. Next up, write the cost per item as a column matrix. Label that one B. So I'm making my cost as a column matrix. Again, I'm adding the little words here. Cost, ba, bat, G. And in my calculator, this one is a 3 by 1. And I'm going to go to my calculator and add this one as well. I'll pull the calculator out of the way so you can still see. But I'd like you to take your calculator out and go to B and edit that one and make it a 3 by 1. So there's my matrix B. It is a 3 by 1. And now we're going to see the beauty of matrix multiplication. Using matrix multiplication, create a matrix C depicting the total cost per store. Okay? Now, just want to go back to the first slide. If I asked you, how much does store P owe? Well, you would say, well, they're buying 70 balls. Balls cost $8. They're buying 30 bats, bats cost $30. And they're buying 22 gloves, gloves cost $75. And you would have no problem doing that math and figuring them out, right? Like if I asked you how much each store and gave you this data, all of you would just go to a pencil and figure it out and have no problem. What we're gonna see now is how matrices can do this for us. So here is our big first one. You can just write A if you don't want to rewrite it. Then we're multiplying by our cost matrix. And I'm going to add in purple here. Well, that's not purple. That looks purple. There it's purple. Ba, bat, G. And this is a 4x3 and that's a 3x1. Which means the middle numbers match up. But what's really important in matrices is that the middle numbers have to match up in word problems and represent exactly the same thing. So you see how we have Babaji and we have Babaji there as well. If the middle didn't say Babaji both times, you could still multiply them together and you would get an answer that means absolutely nothing. Matrices can do that. You can get answers that are like, yeah, that means nothing. All of those numbers have no real significance whatsoever. But if they match up, your answer matrix is going to be the 4x1. And your answer matrix not only is going to be the 4x1, but the 4 stood for P, Q, R, and S. And the 1 stood for cost. And boom. In one multiplication, you have the total cost of all of those. Because what happens? Remember matrix multiplication. Look at store P. This is how much they ordered. Turn it on its side. Bring it back. Release it. Crashes into the 8, the 30. I don't know why I have 8.0. And the 75. You'd pick up all those pieces, add them together, and that would be your total cost. So the 4x1, that 4 stood for the PQRS. The 1 stood for cost. And not only do you get an answer, but you all know what the answer means because of the matrix. And on our calculator, what we can do right now, so I'll move it to the side, is I can take my matrix A, I can take my matrix C, so in my calculator, again, you find them, go second matrix, just highlight A, second matrix, just highlight C, push enter, no, something went wrong. Oh, it's got to be A times B. Take matrix A, take matrix B. Yeah, that matrix C that meant, wow. There we go. There's matrix B. A times B, boom, there's our answer. And you can use your store button and go second matrix and go down to C. And now you don't have to write those in. It just automatically now has that information in there for us in C. Really cool. So, yes, you could have answered this without matrices. But kind of nice to see how the matrix multiplication, if you've got a calculator, could put this information in there. It did a lot of math for you. Okay? So could AI. Okay, I know. Right? But maybe the AI is using matrices. I don't know. Matrix D includes a 2% shipping charge. 2% would be multiplying by 1.02. I can just get this. I could, this is pretty easy, multiply each one by 1.02. Or I could go to my calculator And just do 1.02 times matrix C, and this is supposed to be matrix D, so I'll store it as matrix D. Maybe I need that later. Oh, this is each, oh no, this is not matrix C. I did a total shipping charge. So
have to solve it if it just says create matrix D.
this would be fine. If you're thinking AP calculus wise, it's like this is just what you need to do. So it's just the 1.02, and we can write the answer from our calculator here. This is the total bill with shipping charges. $372.20, $255.10. And that is actually part E as well. Part E in your question, you can skip it because that's your total cost that each store is going to have to owe you. Can you figure out, using this one here, this is how much each store owes. Can you show me, with matrix multiplication, how to find the total? I know you could just add them up. That's what I would probably do. If someone said, how much is in total, are they gonna get? I just add up all four of those. Can you do it with matrix multiplication? What would you have to multiply by? Total amount? If I wanted to add them all up, what would have to be here? 1, 1, 1, 1. All those ones would crash into there. Flying those numbers out. Pick up the pieces. So I would say applying these matrices to word problems is probably the hardest thing we've done so far in matrices.
Nice parking.
Yeah, I can test it. It's great for it.
Okay, next example. Ooh, viruses have been in the news. A virus hits the students in cruise ship school. Nurse Bertha discovers that students are either sick, well, or carriers of the virus. Right? That was the big scare with the hantavirus thing. They're like, these people are carriers and they may get off the ship and not know they're sick and then get other people sick later. There was someone who got off the ship that lives in forget what islands. There's these islands that are the farthest island from any other land in the world. They're in the Indian Ocean. And there's only like 200 people that live on this island. It's a British island. I think it starts with a K. No, Canary is with the C.
I know, but
Canary Islands is where the ship is right now that had all the sick people. But one of the people got off that ship early, went back to his home island of Kiributi or something. And you can't get to this island except by boat. And the boat ride is like 5 days. It's like far. I don't know. That might be a little bit off. I'm just making up numbers to sound plausible. But it's really remote. And so they actually brought in a military plane with paratroopers, a doctor, and a nurse, and dropped them over the island to treat this guy that had hantavirus on him. True. I will see if I can find the name of that. Okay. So you are either feeling just fine and you don't have it at all, you are actually sick, or secretly you have it inside of you and want to share. You're a carrier. Here's the student population on this boat. 104 males, 80 females, 107 in grade 12, 103 females in grade 12. And so we can make a matrix A. And we can make a matrix B. And we want to make sure that not only do the numbers match up in the middle, but the rows, the columns from the first matrix, grade 11 and 12, have to match up with the rows from the second matrix. And if they do, and we multiply them together, we can find out the following. 42 males are feeling well. 69 females are sick. 89 males are currently carrying the virus. And so the matrix multiplication takes a whole bunch of complicated data and allows us to multiply them together and be like, well, how many males are sick? Well, that's actually easy. You just look at your new matrix and pick out the correct number. How many females are well? Well, female 38. Again, one matrix multiplication. And again, you'd probably put this into your calculator and figure it out to do it as quick as possible. How many carriers are female? My chart's 76. Now, both of these first two questions led you a little bit. They led you because they gave you charts. And those charts made it easy to write your data down. Actually, the first question for the column matrix for the cost, that wasn't in a chart. The question is, how would you know to make a column matrix? Well, in your mind, you're always thinking about what are things that I can match up in my two matrices? And one of them has to be in the rows, and the other one has to be in the columns, and they have to match up. And that leads us to our next question, where the data isn't given in a chart. It's like, a whole big essay to read with a lot of data. Sound company produces stereos. They have 4 models: the budget, the economy, the executive, and the presidential. The budget model needs 50 transistors, 30 capacitors, 7 connectors, 3 dials. And each of them tells us all of this information. How many transistors are needed per day? How many capacitors? How many connectors? Because the daily manufacturing goal is 10 budget, 12 economy, 11 executive, and 7 presidential. This is a lot of data. You could take this data and without matrices, you could like brute force figure out a whole bunch of stuff. But your math would be all over and you'd be like very unorganized. And so this is the beauty of matrices. And there's more than one way to do this. Okay? But what's going to happen is you're going to I'm going to take the first set of data, which is the budget, the economy, the executive, and the presidential, and how many transistors, capacitors, connectors, and dials that I need. And I'm going to put it into a chart. And then I'm going to look at the rest of the stuff that I have and notice it has other data with the budget, the economy, the executive, and the presidential. Right? Which lovely spells a swear word, which we beep out. Okay, so because they have this beep right here, we need to make sure that this other matrix also has the beep. So we write the beep across the top. And we know how much they have and want per day. 10 budget per day, 12 economy per day, 11 executive per day, 7 presidential. And I have to write that matrix B in the front because I made my beep the rows in my second one. So my beep has to be my column in my first one. Right? This 4 is my beep. This 4 was my beep. They match up. Beep, beep. And my answer is going to be, oh, this is a 4. There it is. My answer is going to be a 1 by 4, and my 1 is my per day, and my 4 was, oops, that's capital B. TCACOD. Okay. Good. A 1 by 4. And when I multiply those together, they match up, the beeps match up, and our answer here gets all of that data really quickly. You need 2,810 transistors per day. It's just a really, matrices provide a really nice way of organizing complex data. And once your data is organized, you can be like, oh, I can multiply these together and get a whole bunch of other information really quickly from that. And of course, with the use of technology, you don't have to do any of that math. But you could, right? If you wanted to, you could take the row and multiply it by the column, add up the pieces, and get each of those answers. So we've answered how many transitions? We've answered part A. From that, I don't know if you need to rewrite it. And again, if we were doing this question, we would take out our calculator, put this information in. Then in part B here, it's asking us to figure out that during August and September, everybody's listening to their music. They want their stereos on. Production needs to go up. Increased by 40%. How many budget, economy, executive, presidential models were produced daily during these months? Well, again, you could figure this out. You could take each of the amounts per day and multiply it by 1.4 and add it up. Or we could just take our matrix B, which already had the totals per day, multiply it by 1.4, that's just a scalar multiplication. In manufacturing, can you make 16.8 of something in a day? Probably. You're just not finished it. Just needs to finish it the next day. Depends on the company. Maybe that company would be like, no, if we're starting one, we need to finish it so that we're starting the next day. But I think lots of places could be like, we're halfway done. We'll finish the other half tomorrow. I try to use inclusive language in this next one because normally they talk about historically they talk about man hours, but I don't know what the person hours is what I went with. 5 person hours to produce the budget model. 7 person hours for the economy model. 6 for the executive and 7 for the presidential. How many employees do you need to maintain a normal production? Everybody works on average 7 hours per day. So how many do we need in normal? How many do we need in August and September? So again, we have our beep. We're going to make a new matrix here with the hours. And why did I make it a row matrix? Maybe I shouldn't have. Beep, beep. Those are hours and hours. That's not what I wanted here. This one, matrix B. Let's go back to our matrix B from before. I have it right here. That is per day. 10, 12, 11, and 7. Let's go back to here. This is per day. Gotta erase this. This is per day, 10, 12, 11, and 7. And then my hours needs to be a column matrix so that my beeps match up. Yes.
It says in August and September, are we using that increase?
We will. It says, this question has lots here. It says in August and September, but then it says determine the number of plate and the normal production as well. So I'm just doing the normal production first. And then I could just take that and multiply it by 1.4 in the end. So if I do that beep, do you see what I'm going to get as my answer? My answer is going to be a 1 by 1. And my answer that's a 1 by 1 is going to be per day hours. Okay. Just like that, I can figure out I need 249 hours per day. Right? Each person works 7 hours. I need 35.5, about 36 employees in a regular schedule. Right? And then August and September, I'm going to take that 249, multiply it by 1.4. We need 348.6 hours. Divide that by 7. Have to hire 14 more employees. So definitely take some time to try the word problems on that handout. Because this is something, it takes a little bit of skill to set up the matrices. But they're really cool how they get the answers.